See, make it easy for you. Stopped and restarted. So I had 2 recordings. So now we're going to talk about something called REST and Spring. Spring is a REST framework. Yeah, it's a backend framework, sure, all those things, but it's actually called a REST framework. REST is going to be relatively important because we don't actually want to use the templating engine. We want to create REST endpoints, which our Angular system will then be able to connect to. Remember, we have server side and client side, so there's always an interface. There's always something between them. And in our case, it's going to be REST. We'll talk about what that means in a minute. But explain the fundamentals of Spring for developing applications and version control. Discuss REST and REST services. It's a really easy concept, but relatively important. Explain the architectural style of applications built using REST services. Architectural styles make it very easy to understand how frameworks are put together. And then we discuss REST and HTTP methods, how they're related, and then JSON. Now, I say JSON, like Jason, but with like an emphasis on the J, like JSON, right? I've had people pronounce it 100 different ways. I don't really care, but that's what I mean. JSON, JavaScript Object Notations, what that stands for. And it's used as a medium, right? Right? My, I was going to say, it's my tarot card reader asked me to get, told me he didn't want, I forget the joke, I'm just screwed up. Told me he didn't want the smallest, don't get him the largest because he's a medium. Terrible joke, sorry. Sorry for doing that to you. One of the most important elements of modern full stack development is version control. Almost all of our frameworks do generic tasks very, very easily. And what we're going to do is we're going to tell it, hey, do this generic task, but use my object instead of whatever crap you might use generically. And like I said, we already said that separately. So frameworks provide, among other things, an Ioc container, which provides a consistent means of configuring and managing Java objects. So for our server side, what do we want to do? We want to take those data access objects and do what with them? Get them, get one, change one, delete one, add one, right? Those type of things. And so that's what we're going to do. It's the consistent means of configuring and managing Java objects. So we define the objects, but only the data. The container is then responsible for managing object lifecycles. When do we create them? When do we go delete them? And so forth. Objects created and managed by the containers are called managed objects or managed beans. We configure the container objects by either writing them in XML or annotating POJOs. One of my favorite new, it's my favorite, literally my favorite new algorithm. Because first of all, it sounds like POJO, right? That's kind of cool. But second, it just means plain old Java object. There's a million ways you can annotate things, right? There's a million ways you can specify things like a Java object. What's the easiest way? Just to write a really simple Java object. But then how do I describe that I just mean a really simple Java object? I had to create an acronym for that. Plain old Java object. Like pots. You ever hear somebody talking about the pots? Nope. Plain old telephone service. POTS connection went down. Means telephone line went down. Anyway, I apparently never heard that either. I'm old again. How many of you have a phone?
A cell phone.
No, like a phone that plugs into the wall.
Those don't exist.
You see, we got one. What about you, Trish?
I do have one. It's one I used to have when I was in middle school. It's a hamburger.
No. Is it actually plugged in?
No, not anymore.
I like the hamburger phone, by the way. Yeah, awesome. I was never allowed to have any cool phone. I had old hand-me-down work phones. So, you know, the kind that you can pick up and murder someone with. I shouldn't have said it that way, but you know what I mean? Like, no, but you know, like the phones you pick up and they're heavy.
The ones that look like bricks.
Well, no, well, it wasn't so much for brick, but like, You picked it up and it had like
Oh.
a steel bottom.
Yeah.
So it was, people just don't understand. Like, even when I was a kid, like with the rotary phone, people had rotary phone like that were super light. Not in my house. You need the muscles to pick up the phone. No, I'm joking. But we certainly, like, you ever see those people that walk around with the phone? That was not me, right? Because the phone thing was heavy. But anyway, plain old television service, if that was down, that meant your telephone cable connection was down. Anyway, we obtain them through dependency ejection. It's a pattern where the container passes objects by name to other objects. So your server object, we're going to have a server object, is going to use, we're just going to insert the name in there, and then it's going to ask things by name. Via constructors, properties, or factory methods. You're like, wait, what? We'll see that as we go along, but it's actually quite simple. The Spring initially was just an Ioc container, but now it's an application framework that allows you to build EE Java applications. We're not going to go into enterprise Java applications that can create. You can actually create cell phone applications using Spring as a backend. And then you can actually use Angular as a front end as well. But Spring is a configuration model where Spring handles many common concerns, such as things like HTTP requests, connecting to databases, and so forth. Basically allowing you to focus on what your logic requires you to focus on. That's it. Ta-da! We developed the business classes and annotator classes with Spring annotations, and Spring just takes care of the rest of it for us, including validation. Right, when we accepting data, like a student that comes in, when we accept data like a student, how do we know that that student's well formed, right? Like it's got a student ID that's in the right format, right size. It's got a name that's not over a certain length, and it's not blank, and those type of things. How do we? Spring we just set annotation, we set some rules in our Pojo, tell it to validate, and voila, it validates. It's actually quite easier, a lot easier than what we used to have back in my day, right? See, it's like my fourth old person accent. I'm ancient to your standards though, right? I'm 48, right? That's really old.
My dad's 41. I can't.
No?
No.
Oh, yeah. So, all right, not too bad. Okay. All right. Well, I appreciate it because y'all are just being nice. Must have been the cookies on Monday. You missed out on cookies. I think you missed out on cookies, right?
No, I heard.
They were all right.
They were pretty good.
Yeah. So, yeah, they went quickly. So, but anyway, Spring is a huge framework that has several setup and configuration steps, build and deploy steps, and all those things. Right? We're actually not even using raw Spring. We're actually using something called Spring Boot. Because what we're going to do is we're going to have all those setup and configuration steps, including Tomcat, including the web server part of Spring. We're going to tie all that together in Spring Boot. And you go, wait a second, what? Remember our opinionated? You should set up Tomcat this way. Well, let the guy have an opinion, right? We are going to set up Tomcat the basic way. We are going to set the web server the basic way. We're not going to change any of those things. So let them do it. And that's what Spring Boot's designed to do. It's just designed to do everything for you. It addresses all these concerns, abstracts all the steps, and allows the user just to focus on the business line. We don't have to worry about servers. We don't have to worry about any of that crap. Spring Boot will actually handle all of it. It handles the complexity of configuration of Spring framework by taking most of the work away. You're like, wait a second, what? Done. It's done. It's all done for you. There are some things we'll do to configure in Spring Boot once we have it, like database connectivity, like we want the server to load up on this port. We want this to happen on this port. We want this to happen this way. But for the most part, because we're swimming in the direction of the current, swimming in the same direction as the current, we're just going to be floating along, doing our thing. Most of the work is going to be done for us. Yay! So Spring Boot focuses on no war, only jar. hate that. So it sounds good, but it doesn't rhyme. Should rhyme. Doesn't. But WAR means web application resource. It's a specific way to deploy JSP type web applications in Tomcat-like servers or Java type servers, but they're called web application resource files. And they have to be, you have to insert them in the right place. You have to tell the server, hey, this WAR is here, right? You have to do quite a few things to make that work, believe it or not. Jar files, on the other hand, are designed for idiot and all of us. And you go, wait, what? Did Michael Root just call me an idiot? Yes. Yes. We all forget how to run things. We all forget things. We all blah, blah, blah. Jars are designed to just run. Remember I said some things are just designed to just work? Some things are designed just to do that. This is one of those. So without having a war and just focusing on jar simplifies a lot for us. We'll literally be able to just run the code and it'll run the application, and we'll never have to worry about, is it running correctly? Is this working or is that work? Nope. All that's done for us. You don't have to generate a WAR file, upload a Tomcat instance, and do any configuration. You create a self-hosted standalone application which are executable via the jar. Deployments of Snap. Suppose you were running a server in Amazon Web Services, right? You created a deployment server. You just send the jar up to the deployment server. You make sure Java is installed. Okay. Run the jar, and now you have a server running. That's what it's designed to do. Why is it designed to do that? Imagine you were going to create 10 Amazon instances. You put the jar up, create the 10 instances, you're done. They would run and then we have 0 issues. It makes deployment really designed to make deployment a snap. You can unpeel the layers of Spring, unpeel the layers and do things special and all those things. Real production servers don't. We just use jar, right? And so that's what Spring Boot was designed to do. Primary goals, I'm gonna skip that because I want to go quickly. Well, no, I'm gonna go say quickly. It's provide production-ready applications and service with minimum fuss that people can just run, right? So it's designed just to be able to create a runnable application. Typical servers require a lot of configuration to make it safe and all those things. But generally speaking, for most things, we set the same exact settings every time. To be opinionated, which means making certain decisions for developers, which are common. Support convention over configuration. We want to avoid XML configuration. We want to avoid configuration steps, massive amount of configuration steps. We assume that everybody wants to do it the same way. Now, what happens when we assume? Makes an ass out of you and me. We end up with problems. But as long as we're all doing the same thing with the same application, we're all good. It's only when we have to go against the stream that we have to do extra work, which is what the Spring Boot is designed to do. And of course, we can customize it as well. As long as we're customizing small aspects of the server, good. We're trying to change big aspects. That's where we run into having to really get back and configure it. So we're going to use Spring and Spring Boot to develop REST service and endpoint. We should really understand what those are, don't you think? Right? When you talk about REST. REST is representational state transfer. So software architectural style that designs a set of constraints to be used to create RESTful web services. Okay. I freaking hate when definitions are circular. It's not truly circular, but it is circular. Software architectural style, REST. It defines a set of constraints to be used for creating RESTful web services. Again, what's RESTful? Web services are what we consider web applications that are service-oriented. Services are also an architectural design style. Basically, we offer a simple, well-defined set of services that define that some other set of applications can come and build more complex things. Yes? That's what a web service is. Okay, so we got that. Okay, so something else, we're going to build things that other people are going to come and use. but we still haven't talked about the REST architectural style. They're designed to provide a high level of interoperability between computer systems and the internet. Okay. Still not there yet because it's still just, we're talking in circles. RESTful web services allow the requesting system to access and manipulate textual representation of web resources using a uniform and predefined set of stateful operations. That's it. Put the two things together. Okay, representational state. We're going to create a representational state of our objects that we want to maintain and operate with, right? Remember our data access objects? List of students as an example, or student or whatever, right? We're going to provide a way for you to access and manipulate textual versions of those objects via a uniform and predefined set of stateless operations that some other application is going to come and be able to request. That make sense? That's what RESTful means. Unfortunately, all these words mean something. If you're ever in an interview and somebody asks you what that means, what a web service is, what a RESTful web service is, those type of things, it's easy to break it down. As crazy as it sounds to explain it this way, it's one of the easier ways to explain it. So architectural policies and properties, I'm not going to go over all these, but performance and component interactions, which can be a dominant factor in user perceived performance, designed to do this for efficiency. What is the slowest thing? When we think about going on a browser, going to a web server, what is the slowest part? Always, and it's easy to answer, the network. The actual internet is an actual network. Your data is not at your fingertips. Your data is sitting on some server somewhere, and someone has to go get it. Now, granted, that doesn't take long to get, but the more time I'm spending making the data look the way I want, away from the server, away from the computer, the slower it is. This is actually a way, using RESTful services, to speed up the operation. Just get me the data. I'll figure out how to make it display locally. By doing that, I speed things up. Scalability. So part of the way REST works is because we use well-defined interfaces, we can scale the snot out of these things. It can build 100 servers, and any server, any application can hit any one of the servers, and we'll get the same result. Simplicity of a uniform interface, obviously. Modifiability of components to meet changing needs. If it's a simple application that modifies things and returns data, your server is actually quite simple, right? It doesn't do a whole lot, and therefore it's really easy to modify something, right? When you separate concerns, changes become easier. It's essentially what that is. Visibility of communication between components by service agents. You can actually sort of monitor the data that's being transferred. If that's something you're interested in, it's very easy to see. Because we're dealing with different components, suppose we have a problem with A component, but we're using B and C components. Well, how do I know where the problem is? I can look in between the two components, the three components, and say, oh, well, the data being transferred between the B and C component is good, accurate, there's no problem. B sending the accurate data, so the problem must be in the code, right? So that's what that's trying to do. That's why it's visible. That's why it's important for it to be visible and simple. Portability by components by moving program code with the data. We want to make sure that well, that's a separate concern. I should have taken that out for this class. But we have something now called microservices. And microservices can actually return data and they can return code. So we'll leave it at that. I won't go into detail, but we can actually return code. So you can actually send the code to manipulate the data with the data, but we won't get into that. And it tends to be reliable because the simpler things are, the less likely they blow up. Easier to get right. It's also client server. This gives us separation concern. We try to be stateless as much as possible. Session state should be held within the client. This is not entirely possible. We'll talk about this quite a bit when we get to sessions. Cacheability of data should be cacheable as much as possible. The simpler it is, how more cacheable it is. Layered system, there can and should be go-betweens. We can actually put application filters between the applications. And if we don't want people to access certain data, we can actually groom it, massage it, do whatever in between if we choose to. And also the go-betweens is another way of saying we can put web caches in between the servers and speed up operations. If you want, though, you can ignore it. Code on demand, we can send executable code. This is what happens in microservices. I want to learn more about that, but I haven't actually had time. Uniform interface, it actually simplifies the architecture, right? It simplifies. Is it my web server that's the problem, or is it the client code that I'm writing? Which is the real problem here? You'll be able to determine that very quickly, which is why we do it. So uniform interfaces, resource identification in requests. Individual resources are identified in the request. The resources are then conceptually separate from the representations that are returned to the client. You go, wait a second, what? We're gonna go get data out of the database. We're gonna send a representation of that state of the database to the client, yes? Whatever that request is. That representation is different than what's actually in the database. You can manipulate client side on the client side, the data, without necessarily manipulating the guy back here, right? Because they are actually separate. Resource manipulation through representation. When a client holds the representation of resource, they make a modification, they can send that to the server. And by sending that to the server can use that representation to make a change to the actual data. Self-descriptive messages, they should be actually descriptive. I'm going to skip the last one. Hypermedia is the engine of application state. In a true REST application, which we're going to avoid because we're really focused on the web application, you might actually the client is kind of dumb, and the options that it has next are given to it via, like, its options of next or type of request can be given to it in the in each response, right? So it can actually, the server can actually control the state of the client. We're not doing that, right? We're doing a simple web service. Web service APIs adhere to the REST are called RESTful APIs. HTTP based REST are defined with the following aspects. All of the things we're going to do are HTTP. So base URI, so they'll all have a base URI, and then you add things on to the base URI to identify which request we're interested in, right? That's how we differentiate endpoints. Standard HTTP methods are going to be used: get, post, put, patch, and delete. We'll talk about those in detail. You know about get and post. We talked about get and post. HTTP has several other methods which are going to be used in a RESTful session because it's very easy to differentiate between the different type of requests. Media type that defines state transition data elements. You go, wait, what? We have to have a media type to go between. Servers, the client's going to request something, server has to send something back. What is the server going to send back? We keep talking about representational state, a textual representation. Sounds like sexual, but it's textual. I don't want to know what is sexual. Yeah, no, we're out. Anyway, what does that actually mean? We actually have to send a media type that is text-based back and forth. The current representation tells the client how to compose requests from transitions to the next available application. Be simple as URI, as complex as a Java app, right? You go, wait, what? Text. Text can be code, right? Code can be text, yes? Hence, that's why we talked about code. Most of the time, though, we're talking about a media type that's going to go between. I said medium earlier. All right, we're kind of at a place where I'm going to run out of time. Oh, let me go over the URI and HTTP methods, and then we'll stop. Okay, I think I should have time for that. So the HTTP methods: post, get, put, and patch, delete. How are they intended to be used in REST applications, as well as how they're intended to use in HTTP APIs, right? So how they're intended to be used. Post is missing for whatever freaking reason, is to usually add, right? Get is to retrieve a representation of the data in the response body. Now, get could be all the items or a specific item identified and using some mechanism. We'll get to that later, but it could be all of them or it could be just one, right? And we can retrieve representation of that data in the response body. Put, store the representation in the request as the new state of the resource. Put is designed to replace the old, essentially. Put assumes that there is something there. Post puts the data in the database, but it's not necessarily there. But put, store it as the new state. That's actually why, now that's why post is missing. But anyway, whatever. Patch is to update some part of the resources state using instructions in the request body. Wait, what? We don't use patch that often because it's a little bit more complicated using Spring and the REST frameworks that we use. But basically, we don't actually send a representational state. We actually send part of the resources state and with instructions on how we wish the state to be manipulated. You remember update SQL query is update students where, or no, set ID equals to this, if this, right? That's kind of what that's happening in patch, okay? We avoid this like the plague. We almost always use put. We'll see that in a minute. And delete is designed to delete the item. So how is typically used in REST? Post is used to create. Ta-da! Not very interesting. The URI of this created member resource is automatically assigned and returned in the response. Not necessarily, but it is. Get is to retrieve the URIs. Put is to replace the representation with the one given. Patch, update the representation using instructions. Now, we're going to avoid patch like the plague, but delete. Now, this is where things get a little awkward. Remember earlier I said how they were intended to be used. We had items or a specific item. This is for items, a group of items. So what does post do? It takes a group of items and inserts them in the database. Get gets a group of items. Put puts a group of items. Delete deletes a group of items. This one is for a specific one. It creates it, it gets it, it puts it, it patches it, or it deletes it. But it's for a specific one. Yes? And the difference between them is actually quite simple. One uses the base URI. There's nothing added to it. And the other one uses the identification of, say, item 3. So it uses the base URI / item 3. Remember I told you that we're going to use the base URI, and then when we want to specify different endpoints, we're going to specify things in the URI. This is what that is. It'll make more sense when we see the actual code, to be honest. But yes, the big thing to remember is post, get, put, and delete. Get gets the resource. Post adds the resource. Put updates the resource, or changes or replaces what's there with what you're giving it. And delete deletes it. That's the big thing to remember. All right, so we're going to stop at media type. Still a day behind. Half a day.
Might have to cut off the then.
Yeah, I'd rather cut off your arm, but sure. So no, because when we get to the end, we can easily cut the end off, right? That's not a problem. The problem is we need to, with the deadlines I'm concerned about, the homework's not the, what's called it. You had everything you need to do homework 1 before I gave it. I want to get to the same point in homework 2. That's it. That's all I'm going for. Anyway, media type is going to be so much fun. So anyway, y'all have a great day. Make sure, wait, before I say this to lunch, how do I get this canceled? Make sure you come to class in person or on Zoom during class times. I may or may not record just one of these days, and it may be important for homework. So remember, recordings are for luxury purposes, right? because I'm being nice, just like when I brought y'all cookies. Just like cookies are a luxury. You don't get cookies every day. How many of your other professors brought you cookies? Never had it happen before except for me. That's because I like to make cookies, but I like to eat like one. The whole story behind the cookies is I like to eat like one.
Were they left over for your wife and your son?
Well, no, but the problem. So I make cookies, right? No, like I make a batch of cookies, makes 13, 14 cookies, right? Sometimes 20 cookies, right? I eat like one. Maybe I'll eat another one in like 3 days. They'll eat like a cookie or two. Like those cookies will be around all week. So gotta give them away. I made them special for y'all, but also because the kid, so they're all like, bring me to me, why are you making cookies anymore?